Hi everyone, this is lesson 2-3 on the remainder and factor theorems. And today our learning target will be for students to be able to use long division to factor polynomials. So, we are going to be talking about factoring polynomials using long division to start out. And this first example wants us to factor 6x cubed plus 17x squared minus 104x plus 60 completely using long division if 2x minus 5 is a factor. So in order to do polynomial long division, this should be a review from advanced algebra or 2b, algebra 2b. So when we look at this function, we are going to divide 2x minus 5 into 6x cubed plus 17x squared minus 104x plus 60. And in order to do polynomial long division, we start with the 2x and we see how many times 2x can go into 6x cubed. Now, if you think about it this way, 2x can go into 6x cubed. If you take 6x cubed and divide it by 2x and use your properties of exponents, well, first of all, 6 divided by 2 is 3. X cubed divided by x, using our properties of exponents here, that would leave me with x squared. Remember that if you are dividing like bases, then you subtract your exponents, which would leave us with x over 2, or x to the second power. So, I'm going to respond here that we have 3x squared, but I want to record that over the x squared term. So I'm going to say 3x squared here. And make sure that our squared terms align. So a square goes over the top of a square. And when we multiply, we're going to multiply 2x times 3x squared, which gives us 6x cubed. And then we're going to multiply the 3x squared times negative 5, which gives us negative 15x squared. And in polynomial long division, we subtract our columns here. And we're going to get 6x cubed minus 6x cubed, which these cancel out. Then I subtract 17x squared minus a negative 15x squared. So if you think about it, 17 minus a negative 15 ends up being a plus 15. Double negative here makes a positive. And that would give me 32x squared. And then I carry down the negative 104x. And the next step would be to divide 2x into 32x squared. So again, on the side here, I'm going to take 32x squared, divide by 2x. That gives me 16x. So I'm going to record the x term on top of the x term here. So I get 3x squared plus 16x so far. And now I'm going to do that whole process again, where I multiply the 16x by the 2x, which gives me 32x squared. And I'm going to multiply 16x times negative 5. 16 times negative 5 gives me negative 80x. So 16x times negative 5 is negative 80x. I subtract my columns. Again, 32x squared minus 32x squared is 0. And if I subtract negative 104x minus a negative 80x, that is going to be the same as negative 104 plus 80. Again, we have a double negative here. And a negative 104 minus a negative 180 would give me 24x. A negative 24x. And I'm going to carry down the 60. And this time I am going to divide 2x into negative 24, which gives me and negative 12. Notice that our constant is recorded over the top of our constant here. And when I multiply negative 12 times 2x, I get negative 24x. And negative 12 times negative 5 is positive 60. And when I subtract those columns, I get a remainder of 0. Now, I can check my answer because when we divided here, our answer is 3x squared plus 16x minus 12. And if I multiply that by the divisor, which was 2x minus 5, I should get the dividend, which is underneath the dividing symbol here. So if I multiply my quotient, which is my answer, times my divisor, which is 2x minus 5, that gives me the dividend, which is underneath the dividing symbol. So I should be able to check that answer. So we have a divisor of 2x minus 5, a quotient, or our answer was 3x squared plus 16x minus 12, and if I multiply those two together, I should get my dividend, which was a 6x cubed term. So if it had a lead term of 6x cubed. So if I multiply here by distributing the 2x to each of the terms, I get 6x cubed plus 32x squared minus 24x. And then if I distribute the negative 5 to every term, we get negative 15x squared minus 80x plus 60. Now, if I combine any like terms, first of all, 6x cubed does not have any like terms you can combine with. 32x squared minus 15x squared gives me 17x squared. So those are already combined. Negative 24x and negative 80x give me negative 104x. And so I combine those. I'm going to cross those off. And plus 60, there's no other constant, so I just get a plus 60 on the end. So this was our dividend on the previous question. And so when we multiply that divisor, the number on the outside, the one that's dividing into the polynomial, if I multiply that by my quotient, I should get the dividend, which is underneath the dividing symbol. So I was just checking my work to make sure that we divided correctly, and it looks like we did. So the whole goal of this polynomial long division was to factor that polynomial all the way, that 6x cubed polynomial. And so to do that, first of all, 2x minus 5 is one of the factors. And then we have to factor this quadratic trinomial. So the first thing I'm looking at when I look at this quadratic trinomial here is that there is a common factor. I'm going to look for a common factor first. And my lead coefficient, first of all, x is not a common factor because not all the terms have an x. But I need to look for a common factor amongst 3, 16, and negative 12. Now, the factors of 3 are 1 and 3. The factors of 16 are 2, 4, 8. 2, 4, and 8. And 12 is negative 3 and 4 and 2 and 6. So none of these three terms have a greatest common factor. So the way that I go about factoring this is by using that grouping approach. And we are going to go ahead and multiply the lead coefficient and the constant. So 3 times negative 12 is going to give me negative 36. And I want to list all the factors that multiply to be negative 36, but I'm really interested in the pair that adds to be 16. So if I start with -1 and 36, -2 and 18, if I circle that, I get a sum of 16. 18 minus 2 is 16. So furthermore, we're going to factor this 3x squared plus 16x minus 12 equals 0. I'm going to split up this 16x as 18x minus 2x, and I'm going to carry down the 3x squared term, and I'm going to carry down the minus 12 here, and that's still equal to 0. And then I can group because I have 4 terms rather than 3 terms here. 4 terms allows me to group evenly, 2 terms and 2 terms, and I'm going to factor out a greatest common factor amongst each group. So 3x squared plus 18x, our common factor is 3x, which leaves me with x plus 6 inside the parentheses. 3x times x is 3x squared, and 3x times 6 is 18x. And if I factor out a common factor in group 2, my common factor is -2, which leaves me with x plus 6. And if you look at the two groups and compare them, our common factor is x plus 6. And if I cross off my common factor, that leaves me with 3x minus 2 left over. And remember that 2x minus 5, our divisor, was also a factor because our remainder was 0. And so if I set each of those equal to 0, then I could find the zeros of the function. But I don't need to. We're not trying to find the zeros in this example. They just wanted us to factor the polynomial all the way, which we have. We have x plus 6 times 3x minus 2 times 2x minus 5. Here we are at a check for understanding. I want you to go ahead and factor 6x cubed plus x squared minus 117x plus 140 completely using long division if 3x minus 4 is a factor. Now there's one typo in our responses here. This 2x, which it looks like 2 times 2 here, should be a 2x squared term. 2x squared plus 3x minus 35 is our answer for C. Or part of our answer for C, because you have 3x minus 4 as your other factor. So you have 4 choices here, A, B, C, and D. Go ahead and use long division. Divide that cubic function by 3x minus 4, and then factor that polynomial completely. So we're using long division to factor this polynomial, the 6x cubed polynomial, completely. So go ahead and do that and choose a response, A, B, C, or D, and then press submit. Okay, so in the last example, I asked you to check your understanding by factoring this polynomial completely by using long division. If I take 3x minus 4 and divide it into 6x cubed plus x squared minus 117x plus 140, I would first divide 6x cubed by 3x. So if I divide 6x cubed by 3x, that leaves me with 2x squared. So again, I'm going to record my squared term above the squared term in my dividend. So the squared term should always be lined up over the top of each other. And if I multiply 2x squared by 3x and by -4, I get 6x cubed and minus 8x squared. And if I subtract those columns, I get x squared minus a negative 8x squared. So I have a double negative here. So x squared minus a negative 8x squared is 9x squared. I'm going to carry down the negative 117x. Now this time I'm going to divide 9x squared by 3x. So if I divide 9x squared by 3x, that right here gives me a 3x. So I'll record that 3x above the x term. So the x's align with one another. And now this time I'm going to multiply 3x times 3x and 3x times negative 4. If I multiply 3x and 3x, I get 9x squared. 3x times a negative 4 is negative 12x. Again, I subtract my columns. And a negative 117x minus a negative 12x. The 9x squareds cancel here. But if I subtract negative 117 and negative 12, I end up with negative 105x. And I carry down the 140. And if I divide negative 105 by 3x right here, negative 105 divided by 3, negative 105x divided by 3 is going to give me a negative 35. Okay, again, negative 105x divided by 3. The x's cancel. I get negative 35. My constant aligns right above my constant. So the constant in my quotient, my answer, aligns with the quotient in my dividend. So I'm going to multiply negative 35 times 3x. That gives me negative 105x. And negative 35 times a negative 4. If I multiply quickly, 35 times 4, it's going to be positive because I have a negative 4 times a negative 35. 5 times 4 is 20, carry the 2. 4 times 3 is 12, plus 2 is 140. So I'm going to get a positive 140 here. But again, because we're subtracting the columns, we get a remainder of 0. So far we have 3x minus 4 is one of our factors because our remainder was 0. And now our goal is to factor this quadratic trinomial. Now I can already see that we are not going to have a common factor amongst these three terms. 35's only factors are 5 and 7, and neither of those numbers are factors of 2 or 3. So we're going to have to use the grouping method again to go ahead and factor this polynomial. So I'll set up a little table here. I want to multiply negative 35 and 2, which gives me negative 70. And I want to multiply to be negative 70 and add to be the b value here, which is positive 3. Now I'm going to make a list of all the numbers that multiply to be negative 70. And add to be potentially, what we want to get to is add to be 3. So I get negative 1 and 70, negative 2 and 35, negative 5 and 14, negative 7 and 10, which just so happens to add to be positive 3. 10 minus 7 is positive 3. So that is my pair that I need, and I'm going to use that pair to split up the middle term, which is going to split up into 10x minus 7x. I'm going to carry down the 2x squared, and I'm going to carry down the negative 35, and then I am going to group the first two terms and the last two terms together. And I'm going to factor out a greatest common factor in the first set of parentheses, which is 2x. And I'm going to, if I factor out a 2x, that leaves me with x on the first term and 5 on the second term. And here, if I factor out a common factor, I'm going to factor out a negative 7, which leaves me with x plus 5. And if you compare the two groups, our common factor is x plus 5. And that leaves me with, on the outside in group 1 and in group 2, that would be 2x minus 7. And again, remember that 3x minus 4 was one of our other factors because That was our divisor. That gave us a remainder of 0. So if I multiply these three binomials here, that would give me the original polynomial. That was our dividend, which the dividend goes underneath the divider symbol. So anyways, there's our factorization, and we are done. And I suppose I should mention that this answer in the multiple choice was answer B. Okay. Answer B is the correct response. Okay, so we're going to talk about factoring polynomials using long division. There's a key concept here, and it says let f of x and d of x be polynomials such that the degree of d of x is less than or equal to the degree of f of x. Okay, remember that the word degree means highest exponent, and they're asking for d of x to be a degree less than or equal to the degree of f of x. And the degree of d of x cannot equal 0, okay, because we can't divide by 0. Then there exists unique polynomials, q of x and r of x, such that when we divide f of x by d of x, we get our quotient, q, plus a remainder, which is r of x over d of x. Okay, this will make more sense in a second. For instance, using an example where we don't have a polynomial division, but like if I divided 2 into 5, if I divided 5 by 2, 2 goes into 5 2 times. 2 times 2 is 4. Subtract, I get a remainder here, and when I write out the remainder up on top where my quotient is 2, the remainder then is not 1, it's 1 over the divisor. Right here's the divisor, here's the remainder. So we're going to get the remainder, r of x, divided by the divisor, which was 2. So here we're looking at this. We have, in polynomial terms, we're going to divide the polynomial f of x by the divisor d of x. And when we're done, our answer is the quotient q of x. And then when we're done, if we don't have a remainder of 0, then that remainder gets added to the function in the form of remainder r divided by the divisor d. And so here in this example, the remainder was 1, the divisor was 2, so our remainder is 1/2. So think about it, if I divide 5 by 2, 5 divided by 2 is 2.5, which is my quotient. Now, another way to look at it is to check your work, is that the function f of x, the polynomial that we're looking at, if we take our divisor times our quotient plus our remainder, that should equal our original polynomial f of x. So where some other conditions here, the remainder r of x is equal to 0, or the degree of r of x is less than the degree of d of x. Remember, degree means highest exponent. So r of x is less than the degree of d of x. And the remainder, if the remainder is equal to 0, then d of x divides evenly into f of x. So what they're saying here at the end is if our remainder here is 0, then the function d of x, the divisor, divides evenly into f of x. So another example that's not polynomial division, but where the remainder would equal 0, is 2 divided into 6, or 6 divided by 2. 2 goes into 6 3 times. 3 times 2 gives me 6, and if I subtract that column, I get a remainder of 0. So what that tells me, since my remainder here is 0, I don't have a remainder, and I don't have to add that fraction there on top. So that means that 2 divides evenly into 6. So that happens sometimes with polynomial division, where your divisor divides evenly into the polynomial f of x, but other times it doesn't, and in which case we will have a remainder. So let's take a look at an example here using polynomials. So right here it asks me to divide this function. This is our f of x function, our polynomial. It's actually a cubic polynomial because our degree right here is 3. And we're going to divide that by a function, our d of x here, our divisor is 2x minus 1. And this is a degree 1 polynomial. So one thing you're looking at is you always want the degree of your divisor to be less than the degree of your, what we'll call our polynomial function, or it's actually called the dividend, which they did not use that term in the key concept. But I want my divisor always to have a degree that's less than the degree of the function that I'm dividing into. Now, if I set this up using long division, I have 2x minus 1 divided into 6x cubed minus 5x squared plus 9x plus 6. Now, if I start this polynomial division, I'm going to divide 2x into 6x cubed. And if I look at that, 6x cubed divided by 2x is 3x squared. 6 divided by 2 is 3. X cubed divided by x is x squared. And when I record that answer, since my answer to that, my quotient is 3x squared, I record that answer above the squared term on top of the divisor. So, or dividend, my bad. Divisor's over here. So right here, I have the square on top of the square. Make sure that the exponents align. So the exponents in your quotient align with the exponents in your dividend. So what do I do with that? I don't really need that little arrow right there. I'm just going to erase that quick. Maybe I can't. I'm just going to cross it out. And what I want to do from here is multiply 3x squared times 2x and 3x squared times negative 1 and record my answers underneath the dividend. So 3x squared times 2x is 6x cubed. 3x squared times negative 1 is negative 3x squared. Now remember that I am subtracting each of these columns. So when I subtract this column right here, 6x cubed minus 6x cubed is nothing, 0. And when I subtract negative 5x squared minus a negative 3x squared, since I have a double negative here minus a negative 3, it's actually going to be adding 3x squared. So I have negative 5x squared minus a negative 3x squared. And right here, this double negative actually means a positive. So negative 3x squared, negative 5x squared plus 3x squared actually gives me negative 2x squared. Now I'm going to carry down my next term, which is a positive 9x. And when I divide 2x into negative 2x squared, negative 2x squared divided by 2x is actually going to give me negative x. Negative 1x. Negative 2 divided by 2 is negative 1. X squared divided by x is just x. And so again, watch how this has an x to the first power. This term also has x to the first power. And from there, I'm going to go ahead and multiply x to the first times 2x. Negative x to the first times 2x is negative 2x squared. And negative x to the first times negative 1 is positive x. Now again, I'm subtracting these columns. So you might look at this column right here and think, well, they're not going to cancel because they're both negative. However, if I take negative 2x squared minus another negative 2x squared, these two negatives become a positive, and we end up with 0 there. So these give me nothing, that's 0. And then I have 9x minus x. So 9x minus x gives me positive 8x. I'm going to carry down the positive 6. And I have 2x. I'm going to divide 2x into 8x, or 8x divided by 2x, which gives me, if I take 8x divided by 2x, that gives me positive 4. The x's cancel out. 8 divided by 2 is positive 4. Look that our constant is aligned with our constant in our dividend. And if I multiply the 4 times 2x, I get 8x. And 4 times negative 1 is negative 4. And if I subtract those two columns, I'm running out of room here at the bottom of the screen, so I'm going to just move here to the left a little bit. I get 8x, negative 8x plus 6. This is a positive 8x, my bad. Positive 8x. Minus 8x minus 4. And if I subtract those two columns, the 8x's are going to cancel. And if I subtract 6 minus a negative 4, again, this negative here and the minus 4 become a positive. So I actually get 10 as my remainder. So now what do I do with that? I add on to my quotient. My quotient is 3x squared minus x plus 4. And I'm going to add to that 10 divided by 2x minus 1. Okay, just like when we divided 5 by 2, we took our remainder of 1 and wrote it over the divisor. So this is my remainder, and then this is my divisor, 2x minus 1. So we always write at the end of our quotient, which was 3x squared minus x plus 4, we always write the remainder divided by the divisor unless the remainder is equal to 0, and then we don't have a remainder. So to summarize our answer here, our quotient right here was 3x squared minus x plus 4, and our remainder our remainder was 10, and then our divisor was 2x minus 1. So when we're done, we add to the quotient, and unless my remainder is 0, then I don't have this term here. But if we don't get a remainder of 0, then we have to add on to that the remainder divided by the divisor. All right, everyone, it's time for you to check your understanding. I need you to divide this polynomial 4x to the 4th minus 2x cubed plus 8x minus 10 by x plus 1. Now, I want to make one note because they switched some stuff up here. This function, f of x, this quartic function, because it's a degree 4, is missing a term. And they didn't have a missing term in the last example, but really this 4x to the 4th minus 2x cubed, right here we're missing an x squared term, and you have to account for that when you're doing your polynomial long division. So really what I want you to do is I want you to write out 4x to the 4th minus 2x cubed plus 0x squared plus 8x minus 10. And this right here is going to be your dividend. So in polynomial division, if you're missing any term, you have to put that in as a 0x to whatever power is missing. So make sure that you account for all your exponents. Since our highest exponent is 4, then each term after that should decrease by 1 in the exponent. Okay, so go ahead and complete the polynomial long division and select your answer A, B, C, or D. All right, so you might have been a little confused on this example because there's one thing that's a little different than the previous example we went through. Notice that we are missing an x squared term in our polynomial. We don't have an x squared term. We have an x to the 4th, an x cubed. So if you're missing a term, you have to put in a 0 for that term. So I'm going to put a 0x squared in, then I have 8x to the 1st, and then I have my constant. So when I divide this out, x plus 1, I'm going to go ahead and erase that 0x squared for a second so I have some extra room. If I divide this out, when I write out my dividend, I'm going to do 4x to the 4th minus 2x cubed plus 0x squared plus 8x minus 10. Now, what's going to happen here is we are going to go ahead and divide x into 4x to the 4th, which gives me 4x cubed. If I multiply 4x cubed times x times 1, I get 4x cubed. Oh, That's 4x to the fourth plus 4x cubed. When I subtract, I get nothing here. 4x to the fourth minus 4x to the fourth is 0. Negative 2x cubed minus 4x cubed is negative 6x cubed. I'm going to carry my 0x squared down, and I am going to divide x into negative x cubed, which gives me negative 6x squared. Negative 6x squared times x cubed is negative 6x cubed. Negative 6x squared plus 1 is negative 6x squared. Subtract. And when I subtract these columns, because I have a double negative here, that's going to be adding instead of subtracting. So negative 6x cubed minus a negative 6x cubed gives me 0. Here, 0x squared minus a negative 6x squared is positive 6x squared. Again, because a minus a negative gives me a positive. So I'm going to carry down my 8x. This time I'm going to divide x into 6x squared, which gives me positive 6x. Then I'm going to multiply 6x times x, which is 6x squared. 6x times 1 is positive 6x. And I'm going to subtract my columns, which gives me 2x at the bottom. 6x squared and 6x squared give me nothing. And I'm going to carry down the negative 10. X goes into 2x, a positive 2 times, and 2x, 2 times x and 2 times 1 is going to give me, I'm running out of room again, so I was left with 2x minus 10 over here, and if I multiply 2 times x and 2 times 1 up here, I get 2x, and 2 times positive 1 is positive 2. So when I subtract these columns, I end up with a remainder of negative 12, because negative 10 minus a positive 2 is negative 12. So at the end here, I'm going to subtract 12, and that's my remainder, and I have to write that over my divisor, which is x plus 1, and that is my final answer. So if we're looking at the multiple choice answers, the answer that matches our quotient right here is letter D.